So this is a quick overview of Sheepl version 0.2. The focus of this release has been around how the tasks are created, how they're executed, and how we can introduce even more randomness into that process. So previously, the first released version of Sheepl 0.1 baked the task list in sequence into the file itself, along with the sleep times. There was also no option for looping that, so once it had completed a time span, that was essentially it. I wanted to look at how I could improve that scenario. So the first improvement in this version is that now all tasks are added to a global array. That array gets called as part of a loop, for which looping is now an option. Also, the sleep times are added into an array. And how this works is that once this is executed on a loop, it will select a task at random from the list, and it will iterate through that array. The array gets shuffled every time it goes through the loop, so the sequence of tasks is randomized every time it goes through that loop. Also, the sleep times are randomized as well, which means that you never really know which task and which sleep time go together. I think that this is a valuable addition. It's required some architectural changes as to how the files are output, but now it really allows us to add in even more unpredictable behavior in how we're emulating our users. So let's have a look at the output of version 0.2. As you can see at the top of the file, there are now some global arrays defined that hold the task lists that have been assigned together with the sleep times, which is chopped up from the total time provided. Further down there's a while loop that takes the original array, copies it and shuffles it to give us that randomness. For this example, I've reduced the sleep times just to make it easier to give you a demonstration. I've also added in some console output so that we can see when this goes through the loop and the random choices of the tasks that are made. The remainder of the file just shows the functions defined based on the tasks chosen. So when we run this, there's an initial console message saying that we're going round the loop, and I've put this in for demonstration purposes. As you can see, the first sleep time is just over 6 seconds, and then the first task is a tea break. It's now picked a secondary sleep time from the sleep array list of 5 seconds, and it's currently executing all 4 tea break functions sequentially with random sleep time choices. Now it actually gets into a useful task, and it's opening up the cmd command shell and just issuing some arbitrary commands just to show control over that. Then it's going to exit out, and it's going to pick one of the 2 remaining sleep times that are available in that list. It finally executes the last task that we've assigned, which is the PowerShell command. It has to wait for 10 seconds for the command shell to appear, and then it's just going to issue a getWMI call to the Win32 BIOS. It exits, and now it goes around the loop again. And you can see that the first sleep time this time is just over 4 seconds. It differs from the first. And on this iteration through the loop, the very first task it executes is the PowerShell task that it was assigned. Again, calling exactly the same call, and then exiting out. Due to the fact that there are a number of tea breaks assigned to this task list, just purely for demonstration purposes, it's not necessarily very useful. But as you can see, it's picked 2 more tea break randoms, and it's also picked random sleep times out of that list. A task and a sleep time are no longer bound, and they can act randomly, so we never really know within any given loop which task is going to be executed and how long we're going to have to wait until the next task is going to be executed. We now enter into the final loop, and again it's chosen a random sleep time as the very first point, and now it's going to be executing PowerShell again as the first task it has been chosen. This really is all random, that's just because we've got a very small list of tasks given over a very short period of time. So I think you get the message at this point. So the purpose of this is that we don't really ever know which task is going to be executed and which sleep time is going to be chosen, how long we're going to have to wait until the next task. And if you scale that up to a greater number of tasks over a longer period of time, it becomes very difficult to be able to determine when a task is going to occur and how long you're going to have to wait for the next one. And that's really the purpose of all of this, to introduce much more randomness or entropy into this solution. So I hope you enjoy using Sheepl version 0.2. I've got some interesting features planned for the next release, but in the meantime you can grab this version and the other modules as part of the labseed project on the Spider Labs Git repo. Thanks very much. Cheers.